So this lecture is on perfect square trinomials, which are covered in section 6.3 of the book. Perfect square trinomials have one of these forms. And if that looks familiar, that's because you've already seen those two kind of quadratic equations in chapter 5. That is distributed form of a plus b squared, and this one was the distributed form of a minus b squared. So what we're going to do is work on identifying trinomials of these forms and then factoring them into these forms here. So as an example, if I have x squared plus 10x plus 25, I could try to identify whether or not it's in one of these forms. So the first thing I do is look at this number here, or this last term. And if it is a perfect square, which it is, then that's one requirement. So 25 is 5 squared. X squared is a perfect square. So the only thing I need to look at now is whether this middle term is 2ab. So our a was x, our b was 5. So 10x, if I did 2 times 5 times x, I'm going to get 10x. So this is a perfect square trinomial. So all I'm going to do is take x plus 5 squared, and that would be the answer. It's another example. I had x squared minus 8x plus 16. Look at this last term. The last term will always be positive in a perfect square trinomial, and so will the first term. Both of them are positive. Both of them are perfect squares. 16 is 4 squared. So now I just need to look at the middle term. And that looks like 8 is 2 times 4. So 8x is 2 times 4 times x. So I can write it like that. You have to be careful that you look at the middle term, because I could have a trinomial like that. And so 16 is 4 squared, but this middle term is not negative 2ab, because negative 2ab would be negative 2, thinking ahead of myself here, negative 2 times 4 times x, which would be negative 8x. So this one, actually, if you use the factoring rules from section 6.2, is going to be x minus 8 times x minus 2. So just because there's a perfect square in the last term does not mean that it's a perfect square trinomial. So these ones are fairly simple, but you can get into more difficult examples if you have a coefficient on the leading term. That's 4x, 4x to the 4th. So this one is a little bit more challenging, but I will still check and see if this is a perfect square. So 4x to the 4th is 2x squared squared. So this one is a perfect square. 1 is 1 squared. So then my a is 2x squared, b is 1, so 2ab would be 2 times 2x squared. times 1, which is going to be 4x squared. So that means this is 2ab. So I'm going to go ahead and write this as 2x squared minus 1, quantity squared. As a final example, I'm going to do one where you have two variables. So here, 16x squared is equal to 4x times 4x. So my a is going to be 4x. 9y squared is equal to 3y times 3y. So 3y is my b. So now I'm going to check and see if 24xy is equal to 2ab. So 2ab would be 2 times 4x times 3y. This is 2 times 12xy, which equals 24xy. So I'm going to do a, which is 4x plus b, quantity squared. So that is how you would factor a perfect square trinomial.